Rapid heating and cooling, unlike any CVD before. By preheating the furnace to the target temperature and then moving the furnace itself back and forth around the sample automatically or manually, researchers achieve instant heating and rapid quenching, ideal for advanced material studies. This video introduces our innovative laboratory tube furnace that can perform both RTCVD and conventional CVD processes depending on the selected operating mode, auto or manual. The model shown is SH RTCVD-100TG200-3, designed with a 100 mm tube and 3 independent heating zones, each 200 mm in length. By connecting a chiller to the water cooling ports, chilled water circulates through the end cap, maintaining a vacuum-tight seal. Using the mass flow controller, both inert and reactive gas flows can be precisely controlled. The vacuum pump connects to the port to create a vacuum atmosphere. The back pressure regulator connected to the gas outlet maintains precise positive pressure inside the tube, preventing material oxidation and tube damage during process. Two operating modes are available, auto and manual. Auto is designed for RTCVD processes requiring rapid heating and cooling, while manual is used for conventional CVD operations. This scene demonstrates the operation in conventional CVD manual mode. This scene demonstrates the operation in RTCVD auto mode. Set the target temperature, then press auto and start. After reaching the set temperature, the furnace automatically moves over the sample to start rapid heating. After the rapid heating process is completed, the furnace returns to its original position, and the sample immediately begins rapid cooling. Now, we'll show you a live demonstration using our RTCVD system. Let's take a look at how the furnace performs rapid heating and cooling in a real experiment. After the furnace was preheated to 600 degrees Celsius and automatically moved over the sample reached 600 degrees Celsius in about 4 minutes 30 seconds. After the preset dwell time was complete, the furnace automatically moved to the right and the cooling fans activated to begin rapid cooling. It took approximately 25 minutes and 30 seconds for the sample temperature to drop from 600 degrees Celsius to 80 degrees Celsius. Thanks for watching.